Quadratic Functions Part 3. In this video, you'll learn how to choose a domain that makes sense in a revenue situation. You'll also learn how to relate the vertex of a graph and the zeros of a function to a revenue situation. The vertex of a quadratic function represents the maximum or minimum value. The zero or root of a quadratic function represents when the revenue is zero. And the domain of a quadratic function represents possible values for the independent variable. So let's look at some examples. A company that sells movies online is deciding how much to charge customers to download a new movie. Based on data from previous sales, the company predicts that if they charge X dollars for each download, then the number of downloads in thousands is 18 minus X. So we'll use this situation to fill out this table. So we're given the price, and we'll determine how many downloads will be downloaded, and then the revenue based on that. We know that the number of downloads in thousands is 18 minus X, where the price is X. So if the price is 5, then the downloads must be 13, since 18 minus 5 gives us 13. To find the revenue, we're going to multiply the price times the downloads. So 5 times 13 gives us a value of 65, which in our case would be 65,000. Now let's look at when the price is 10. So we'll subtract 18 and 10, which gives us 8, and then we'll multiply 8 times 10 to find the revenue, and we'll get 80,000. Now let's look at when the price is 12. So we'll subtract 18 and 12, which gives us 6, and multiplying that by the price of $12 gives us 72,000. Now we're going to look at when the price is X. So we're going to create an expression for the downloads and revenue to find these values with any given X value. The downloads will be 18 minus X, and then to find the revenue, we're going to multiply the price of X times the downloads of 18 minus X. If we distribute the X to the parentheses, we can simplify this to 18x minus x squared. And now we can see that this is a quadratic function because it has that squared term. Now that we have the table filled out, we'll use these values to plot a graph so we can see the shape that it makes. We can see that the x-axis represents the price and the y-axis represents the revenue. So we're going to plot the price on the x-axis and the revenue on the y-axis. So for $3.45, we'll go over 3 and then up 45. Now we'll look at $5.65. So we'll go over 5 and then up 65. And then for $10.80, we'll go over 10 and up 80. Our last point is at $12.72. So we'll go over 12 and up 72. Now we can see that this forms a curve, or the parabola that all quadratics form. Now we're going to identify the domain, roots, and vertex for the quadratic equations that were given. The first one says the area of a rectangle with a perimeter of 25 and a side length of x. Here's the graph and function that represents this situation. Let's start by looking at our domain. This is a set of all input values that make sense in our situation. Since we're talking about the area of a rectangle, we need our values to always be positive. So the only x values that make this graph positive are the values between 0 and 12. So our domain is going to be all values between 0 and 12.5 where it reaches. Now let's look at the vertex. This is the highest point on the graph. We can see that this happens at 6.5 and 39. Now let's look at the roots. It crosses the x-axis twice, so we have roots at 0, 0, and 12.50. Our next function describes the number of squares as a function of a step number n. Here's the graph and equation that matches this function. We can see that the domain is going to be all values greater than or equal to 0, since all the step numbers have to be positive. We can't have negative step numbers. Now let's look at the vertex. In this case, it's at the minimum point. And this happens at 0, 10. And finally, we'll look at the x-intercepts, but in this case, our graph never touches the x-axis, so there are no roots for this equation. In this example, a function f represents the revenue in dollars that the school can expect if it sells 220 minus 12x coffee mugs for x dollars each. Here's the graph that represents this situation. So I'm going to put up a few statements, and we're going to decide if they're true or false. The first one says that at $2 per coffee mug, the revenue is $196. So if we plot the point at $2 for a coffee, we go up to the graph where it's around 400. So this one's not true, since it's a lot higher than the revenue of $196 they asked us. Our next statement says the school expects to sell 160 mugs if the price is $5 each. So we'll go to where x equals 5 on our axis and then go up to where it hits our graph. We can see it has a y value of 800. So if we sold mugs for $5 each and sold 160, then we would make $800. So this one is true. Our next one says the school will lose money if it sells mugs for more than $10 each. But if we look at our graph, we can see that the revenue is always positive. It's never negative. So they won't lose money for any value over $10 like this one suggests. The next one says the school will earn about $1,000 if it sells mugs for $10 each. So we'll go to where x equals 10 and see where it falls on our graph. We can see it hits at $1,000 on the y-axis. So this one is true. Now we have that the revenue will be more than $700 if the price is between $4 and $14. This section of the graph represents the price between $4 and $14, and the y values are all above 700 or equal to 700. So this is true as well. Now let's summarize what we've learned. The vertex tells us the highest or lowest point on the graph. The roots of a function can be found by looking for points that lie on the x-axis. And the domain is found by looking for input values that make sense for this situation.